Students, so this is the third lecture for the binary number system for for the syllabus electronics in everyday life as per the Pondicherry University's syllabus. So today we will be discussing, as you can see in the screen, that how do computers process binary data. So in our last two lectures, there was a lecture 1 and lecture 2 has two parts. So in lecture 1 we basically understood the necessity of having a binary number system. And then we had lecture 2. So lecture 2 is of actually two parts. The part 1 was about lecture 2 is basically about connecting binary and decimal numbers. So lecture 2 part A was about, first part was about how to convert decimal to binary, and lecture 2 part B was about how to convert binary to decimal. Now the lecture 3, this third lecture is about how computers process binary data. Okay, so for that we will be going back a little bit to our initial discussion, where I told you that that binary is a language of computers, and computers don't understand any other language, unlike the humans understand the decimal numbers, but computer understand binary numbers only. So if you want to interact with a computer, you must learn binary. And computers use binary because it is a very reliable way of storing data. The main memory of a computer is made up of transistors. As most of you may not, attending this syllabus may not belong to physics syllabus exactly, so for them, again, already I have mentioned that you need not worry much about transistor. Transistor is just simply a switch which works between on and off. So transistor has basically two states. So it can be either high or it can be low, that we have already discussed in my previous lectures. So voltages may be anything, it may oscillate between any value, but usually the voltages, suppose you have something between 0 to 5, say 0 1 2 3 4 5 1 2 3 4 5. So basically what happens, voltages may voltage means transfer through the transistor it may be 1 or it may be 4. It can be 0, it can be 5 also, but even if it is 0, definitely it is low. If it is 5, it is definitely high. But if it is 1, then also it is considered to be 0 only. If it is 4, it is considered to be high only, because a transistor understands only two states. It doesn't understand middle stage or any semi middle stage, nothing. So so now the next question is that, so the voltages may oscillate, but it only takes two values. It doesn't have any other option to consider any other value other than high and low. So such readings are basically done by the processor of the computer, which uses the transistor states to control the other computer devices according to the software instruction. So such readings are done by the processor of the computer, which uses transistor states, means either high or low, to control other devices connected or inbuilt in the computer as per the software instruction. So usually you have, whenever you want to pursue something, you have a software. Okay, first you have a software, and when you initiate the software, the software will give an instruction. Okay, and then what happens, the processor of the computer will take this instruction, and as per the instruction, what it will do, it will use the transistor. It will use the transistor. Not only using the transistor means it is using the two states, either high and low, okay, to control different other devices. Suppose if you want to hear something, then you have some different software or devices connected to the computer. Suppose you want to see something, then you have different device connected to the computer through which you can see. So it initiates that protocol, okay, but it can do it, it can talk to those devices only through a transistor. Only through a transistor it can talk. So next is the main. So what is the main brain behind this system, the system that is working? Like you have a software, you have a software instruction, then the processor is taking the instruction, and then it is asking some other devices to do something using the transistor states. Now, but there has to be some brain behind that. Brain behind such system is nothing but a binary sequence. Okay, and this binary sequence usually doesn't have a predetermined meaning of its own. Instead of it, every data is encoded in binary according to a separate set of rules. Okay, so every data you are supplying is basically encoded with some binary thing. Okay, so binary means with some binary. Okay, and it is obviously a sequence. It cannot be a single binary number always. It can be a sequence of binary numbers. It can be two binary numbers, say string of 2 binary numbers, string of 3, 4, 6, 7, 8, 9 binary numbers, and this binary number, how this string is set, how this string is made, is done by using some rules. Okay, so that rule, how this rule is set up, that we will be discussing. I'm just giving some overview of this, how these rules are set up to give some data to the computer. So here letters are interpreted. I'm writing it so that it can be easier for you to understand. Sometimes if I speak, you may not be able to catch up my words properly. So if I write it, I think it will be easier for you to understand. So it is based on some standard rules, such as, that is called UTF 8. I'm just giving an example. It is not the only one. So what is an UTF? It which assigns each character to a specific group or string. So if you want me to say it's more specifically, so UTF-8 is nothing but a set of 8-digit binary string for electronic communication. So here I am showing the UTF-8 chart. So you can see that every letter, say A, is basically 0 1 0 0 0 0 1. So you can see that it is an 8-digit string. So 1 2 3 4 5 6 7 8, 8-digit string. So A is basically represented by 0 1 0 0 0 0 0 1. Similarly B is represented by another 8-digit string, that is 0 1 0 0 0 0 1 0. Don't worry, you need not remember all this whole of this chart. I am using it just to give you an example. Now suppose that you want to give the computer a message. Say you want to print cat. Okay, so so if you say cat cat to the computer, obviously it will not understand. So that cat has to be the computer. If you want to make the computer understand cat, then you will have to give this data, this, then this, and then this. Then if you give this data in that series as an input, then the computer is going to, for the computer, it is actually, you are actually typing. So the data that the computer is taking is actually 0 1 0 0 0 0 1 1, then 0 1 0 0 0 0 0 1, and then 0 1 0 1 0 1 0 0. So this thing is actually C, this is actually A, and this thing is actually T. So actually what, although the computer is reading it like this, and but for us the language is cat. So this is a simple example, but binary code is actually used for far more complex data. It is just a simple thing that I have tried to show you. It is used for far more complex data. For example, say video. Whenever we can talk about video, so how we see a video through a binary code. Okay, so for this I can't show it specifically here, but I will try to make it as much clear for you as possible for you. So whenever we see a video, each frame of the video is made up of hundreds of thousands of pixels. Suppose you are watching a video in mobile or tab or computer or TV and wherever, so each frame of the video is made up of thousands of pixels, right? So it is called pixels. Okay, so in color images, so whenever we talk about colored image or colored video, so colored video means you have a color image. So every pixel is actually represented by 3 binary sequence. So in a color image, there will be thousands and thousands of pixels. So every pixel is actually represented by 3 different binary sequences. So what are the 3 different binary sequences? First is called red, then is called green, and another is called blue. Okay, so red is basically represented by the binary code 11000011. Similarly, green is represented by a binary code 11000000, and blue is represented by a binary code 10101000. Okay, so these are actually numbers 195, this is 192 and 168. Okay, so that means this basically represents the primary colors. Right, so what I said, whenever you see a colored image, colored is image is made up of thousands of pixels, and every pixel, so each pixel is made up of 3 primary colors, represented by 3 primary colors. And the 3 primary color, for red the binary code is this, for green the binary code is this, and for blue the binary code is this. Now each sequence encodes numbers that basically determines the intensity of the particular color. So whether red will be more, green will be more, or blue will be more will be determined by the sequence, the code in that sequence. Next is then the video. Then what happens? The video driver program transmits the information to millions of liquid crystals on your screen to make different patterns you see. So for watching the videos, you need to have a video driver program. Okay, so the video driver program will then transmit the information. So it will pass the information, means what is the color combination. So what was that? Red, green and blue. Okay, it will pass the information of the content of red, green and blue to the millions of liquid crystals on the screen of the screen. Okay, and based on that information, the screen you will see different patterns. Okay, in this way we are able to see a video and how a computer operates that code, binary codes, to transfer it into a video. Similarly, the sound of this video, because you are not going to see only pictures, video means you have pictures as well as you have the sound. So the sound of this video is also stored in binary. Sound of this video is also stored in binary. Okay, with the help of a technique that is called pulse code modulation, using a technique called pulse. So this is a term that we need not study in detail, we just need to know about it. So continuous sound waves are digitized by taking snapshots of their amplitudes every few milliseconds, okay, and these are then recorded as numbers in the form of binary strings. When they are read by your computer and audio software, the number determines how quickly the coils in your speaker should vibrate to create sounds of similar type of frequencies. Okay, whatever sound you are supposed to create, that will create, it will like simulate the sound. So so I will repeat this thing again. So continuous sound waves are actually digitized. So what happens? First of all, sound waves are, so I'm telling what is this pulse code modulation means. So first of all, sound waves are digitized. How they are digitized? Snap shots are taken, or you can say that snapshots of the amplitudes of the sound wave is taken every milliseconds. And after that, the next step is they are recorded as numbers in the form of binary strings, and then these strings, that means the binary sequence, is read by your computer audio software which finally decides which determines how quickly the coils in your speaker should vibrate to create sound relevant to the video. So that's it about how a computer processes the binary codes to give us images, videos, sounds, etc. and etc. And also how we have dealt with UTF-8 to deal with simple algorithms and simple languages like simple words or the alphabets that we know. So that's it for this lecture. Thank you.